Hi. So this is my final submission for Oblique's warehouse robot task. The objective is to learn a sequence of action that is find, attach, push, and then unleash the box to the boundary to complete the episode. The agent here only receives a 18-bit sensor input, so it does not have the full visibility of the environment. This makes mm, this makes the problem a partially observable Markov decision process where the memory becomes very important. I started with simple heuristic approach and progressively improved the model through DDQN first. Then I moved up to DRQN, then dueling DRQN with rotage experience replay. I also added noisy nets with DRQN, dueling DRQN. Then we go to some. I went to some activated method like PPU, GAE. Then also I used SAC, discrete recurrent SAC, and find it. मतलब it's sort of based out of all these models around minus 1827.8. Although all other were also to similar according similarly, like this one. Also is not PPO plus LSTM engine. The most important improvements were like adding LSTM for temporal memory and using domain randomization across all the difficulty levels and wall settings. Now I will show you the environment setup and how the. So basically the robot operates in a bounded 2D arena. The goal is to locate and push the gray box to the boundary, and the agent uses limited sonar like sensor as I mentioned earlier. So it does not always see the box. To handle this partially observability, my fine model uses like LSTM I already mentioned and entropy based exploration instead of epsilon grading. Also, this is a failure case where you can see the robot is not moving forward towards the box. Instead, it's rotating in its place continuously. This is not a bug. Even it's a drawback, but it's not a bug in the code. Like it's a learned policy behavior. This happened due to mainly two reasons. First, the box is not within the sensor range, so all the sonar readings are zero. The agent is no learning signal. And second is a strong ball penalty. The environment gives around minus 200 penalty per step. So random exploration becomes risky. The agent learns that it is safer to rotate in the place rather than move and risk hitting a wall. So I think despite of this failure mode, discrete stack perform best overall because it uses entropy based exploration, which is slight more stable and it handles partially observability using LSTM memory. Uh, I have trained this in domain randomization allowing to means to for generalization, basically for all difficulty levels and wall and without wall. Also, we can improve this behavior in future, like add more exploration bonuses if it is just rotating, penalize it, or design denser rewards during the search phase. We can do like that.